Pre-Algebra. I have two lessons we're going to review today, 5.1 and 5.2. For 5.1, we have 3 vocab words, and there are 3 vocab words in 5.2. So if you would please do your heading for 5.1 and 5.2, they can be done together, and then do all 6 vocab words. You can pause your video while you do that, and then come on back and I will talk about the vocab. So our vocab words for ratios and proportions, which is 5-1, are ratio, equivalent ratio, and proportion. So a ratio is a comparison of two quantities by division. These things, ratios, end up looking and acting exactly like fractions. So when you have a ratio, say you're comparing boys to girls, and we can write that ratio. Say we have 5 boys and 6 girls in the class. We can write that ratio like this, 5-6. We can write it like this with a colon, 5-6. Or we can write it like this. Looks like a fraction. Acts like a fraction. But really and truly it's a ratio. You're comparing two things. So if we're comparing two things, we can write it in any of these ways. We're going to write it like a fraction because you know algebra loves fractions. The next thing that we are going to talk about is an equivalent ratio. So if we have this as our first ratio, we can do a few things. We can multiply both of our numbers by something. We can divide both of our numbers by something. Either way, as long as we multiply or divide by the same something on both of our numbers, we're going to come up with an equivalent ratio. So say we decide we're going to multiply by 2, we're going to multiply by 2. We get 10, multiply both, we would get 10 to 12. Notice I don't say 10/12ths. Chances are pretty darn good in this section you'll hear me slip and say 10/12ths. But really, because these are ratios, we're going to say 10 to 12, 5-6. But they really do act just like fractions. Last definition for 5-1 is proportions. What we can say, because these are equivalent ratios, they're going to be proportional to each other. Meaning if I reduce this 10 to 12 by dividing by 2, I'm going to end up back to this 5-6. Okay, they're proportional, they're in proportion with each other. Those are different ways that you can say it. They're proportional or they are in proportion with each other. So say you're making cookies and you're going to make one batch cookies. But then you decide you're going to have a lot of people to give cookies to, so you're going to make 2 batches. You need to keep your recipe proportional. So you're going to double all of your ingredients. You're going to be multiplying by 2 everywhere so that all of your ingredients are proportional and your cookies turn out right. So proportions, equivalent ratios, and proportions in general show up a lot in the real world. So this is one of those sections that you will use in life. So pay attention. 5-2, we have 3 more vocab words, and again, these are very real world. So in 5-2, we talk about a rate, which is a comparison where things have different units. So if I say 32 miles per hour, I'm saying that I'm going to go 32 miles in 1 hour. That's a rate. If you're talking about a unit rate or a unit price, you're talking about, like I just did, how far are you going to go in 1 hour? Or how much money does one pair of jeans cost? Or how much is it to buy one season pass? Or how much is it to buy one ticket to a concert? You're figuring out how much money one thing is, or you're figuring out how much is in one unit. So maybe you want to know how many seconds it takes someone to run 1 mile, or let's say how many seconds does it take someone to do, I don't know, 10 jumping jacks, something like that. Well, if we figured out a unit rate, how many seconds does it take them to do one jumping jack? That'd be a unit rate because it's one jumping jack. Then we can figure out easily how long it would take them to do any number of jumping jacks because we have that unit rate. So unit rates are really handy, and essentially you are just reducing your denominator to be 1, which means that you're going to divide both your numerator and your denominator by the same thing and reduce that denominator to 1. So we're going to look at some examples of each of these. Nothing too tough today. So example 1, we are given a ratio that's 6 to 9. We're supposed to come up with 2 equivalent ratios. When you do that, like I said, you can either multiply or divide. So in this case, we're going to come up with 2 equivalent ones. I'm going to say, hey, I can divide both of these by 3. So one of my equivalent ratios is going to be like I'm reducing this fraction. And I'm going to get 2 to 3. Down here, I'm going to say, well, how about if I multiply them both by 2? I will get 12 to 18. So these are both equivalent ratios to 6 to 9. Here I divided both of my numbers by 3, which is fine. If they have a common factor, you can do that. You can divide. If they don't have a common factor, which happens sometimes, like in our first example here, 5 to 6, there's nothing I could divide both of those by other than 1. So I had to multiply here. If that happens and you're asked to come up with 2 equivalent ratios, just multiply by 2 different things. So I multiplied by 2 on the top and the bottom. I got 10 to 12. If I took that same ratio and I multiplied both of those numbers by 3, I would get my second equivalent ratio of 15 to 18. So don't feel like you have to divide and then multiply. Sometimes there's not going to be a common factor, so you're just going to multiply by 2 different numbers to get you 2 different equivalent ratios. The next example says simplify to tell whether the ratios form a proportion. So they give us 2 ratios here, 9 to 36 and 2 to 8. And they ask us to figure out if those are proportional by reducing them. If we reduce both to the same or to the simplest form, so pretend they're fractions, reduce them to the simplest form. If we get the same ratio for both, then we know they're proportional. If not, they're not proportional. So if I reduce this like it's a fraction, I'm going to divide by my greatest common factor, which is 2, and I will get 1 to 4. Over here, I'm going to divide by my greatest common factor, which is 9. And I will get 1 to 4. Because I get the same ratio when I reduce them, I know that these are proportional. So say I had a recipe where I had to put 9 cups of flour in and 36 cups of sugar in, and I wanted to make a smaller batch. If I put 2 cups of sugar and 8 cups of flour, that would be the right proportion of flour and sugar to use in that recipe. Those are proportional. Another thing that you can do here is word problem like in number 3. So they say on average, each American recycles about 1 4/10 pounds of trash per day. And we're supposed to figure out how Ahmed's family is doing comparatively. So they have made a chart for you and said that The average number of pounds recycled per person in the US is 1 and 4/10. Ahmed's family is recycling 7 and 2/10, and they have 4 people. So what you need to do there is see if these are proportional or not. And we can take Ahmed's family with 4 people and say we're comparing that to, or read it the other way, 4 people, 7 and 2/10 pounds of garbage is being recycled. If I reduce this, I'm going to divide this by 4 and get 1. Divide this by 4, and I would get 1 and 8/10. And 1 and 8/10 is actually better than the US average, which was 1 and 4/10 for one person. So we can then say that Ahmed's family is doing more recycling than the average American is doing. So you can compare ratios like that. That actually was finding a unit rate. We found how much each person, the average of each person in Ahmed's family was recycling. So that is going to lead right into 5-2, which is unit rates. In this one, we are given for problem 1 that Nikki can type 120 words in 3 minutes. And they want us to figure out what is her unit rate, how many minutes can she type in 1 minute. So again, just like fractions, we are reducing, we're trying to get that 1 on the bottom. So our unit rates, we want 1 to be our number in our denominator. To keep this equivalent, we have to divide both numbers by 3, and we would get that Mickey can type 40 words in 1 minute. So again, unit rates is all about finding 1 in your denominator. To do that, you're going to divide by whatever number is your denominator on both your numerator and your denominator. If you are looking at example 2, we have a density problem. So we are told that silver for 4 cubic meters, so 4 meters cubed, weighs 41,960 kilograms. And they want us to figure out what the density of silver is. Well, density means how much does it weigh for 1 cubic meter. So we're going to divide by 4 here to get our unit rate. We also have to divide this by 4, which would be 1,049 hundred. So 10,490. Said that wrong. Kilograms per 1 cubic meter. So we have our answer there. That's the density of silver. You would do the same thing with the next one, but notice in the next one they only tell us how much half a cubic meter weighs of aluminum, which is 1,350 kilograms per half a cubic meter. So because this is half and we want to get to 1, we're going to have to multiply by 2 here. If we multiply half times 2, we get 1, which is what we want for unit rate. So again, we have to do the same thing on the top and the bottom. So we're going to multiply this by 2, and we will get 2,700 kilograms per 1 cubic meter, and that's the density of aluminum. How much aluminum weighs for 1 cubic meter. Looking ahead to number 4, these are examples where you are using our distance formula, which is rate equals distance over time. So they tell us the distance and the time, and we're supposed to come up with a rate. So if rate equals distance over time, we're going to say R equals 260 is how far they went, 260 miles, that's our distance, and our time is 5 hours. So if we reduce that to 1 hour by dividing this out, we're going to say that their rate was 52 miles per hour. So that's how you would do a distance formula problem. You're going to plug in what they gave you, which in this case was the distance and the time. We divide that out, we'll get the rate, which is how fast they were going, 52 miles per hour. If they were to give us a problem like example 4, this you might be interested in because it has to do with shopping. So they're telling us that there is a difference in prices of cereal. If you buy a 16-ounce box of cereal, it costs $5.49. If you buy a 20-ounce box of cereal, it's going to cost you $5.99. So I asked you to figure out what is the better deal. Here you're getting more cereal, but it costs a little bit more. So they want you to figure out, is this a better buy because it costs less, or is this a better buy because you get more cereal even though it costs a little bit more? So in order to figure that out, you need to figure out how much does 1 ounce of cereal cost in both situations. So what you're going to do here is divide by 16. Here you're going to divide by 20. And when you do that, you figure out that this cereal is costing $34 per ounce, and this cereal is costing 30 cents per ounce. So keep in mind, if you have a family you're buying cereal for, even though you're only saving 4 cents an ounce, if you think like my family with 6 people in it, we eat like a box of cereal a day. So if we're saving 4 cents an ounce, that's really going to add up in a week, in a month, in a year, in 10 years. It's going to add up to be a lot of money. So these are important kinds of problems that you're probably going to whip out your calculator, right, and figure out what the answers are. But I do that frequently in the store to try and figure out, well, which one should I get? Which one's the better deal? It's not always the bigger box. I think it's always going to be the bigger box. It's not always. Sometimes stores try to trick you, and that bigger box is actually more than if you buy 2 little boxes. So pay attention to what you're buying. When you guys get jobs in the next couple years, you'll start understanding a little bit better that if you can save a little money here and there, it'll really help you out as you go. Alright, so on to some problems. Here are the problems that I would like you guys to try. So page 224, 2 to 10 even, and then page 228, 5 to 9 odd. Try those, submit them, and then watch the homework review. And if you have any questions, make sure you save them, write them down, and ask them in our next Zoom.